Hey guys, today we're going to talk about transforming rational functions. So if you remember back to when we started talking about this, the parent function for rationals are y equals 1 over x, and the graph are the two like L-shaped curves. So to do our transformations, it's almost the same as what we've been doing, but it's a fraction, so it looks a little different. So if we look at our a value, which is our numerator, if it's bigger than 1, it's a stretch. If it's less than 1, or meaning it's a fraction, then it's a compression. So that's kind of the same. On the bottom, that tells us if it moves left or right, and the k value tells us if it moves up or down. Also keep in mind that this one isn't defined as easily to see, but if it's negative, it does reflect over the x-axis. So that hasn't changed at all. So let's look at our first example. So we have a negative in front right here. So that tells us it reflects over the x-axis. Then our numerator is 1, and there is not a coefficient in front of the x right there. So that means we do not have a compress or stretch. Then we have this +4 on the bottom. So we go opposite based right here. It says always change the sign of h. So that means that this is going to go left 4. And then lastly, this -6 tells us we go down 6. So let's look at number 2. The 2 on top will tell us that this is a vertical stretch by 2. And the -3 on bottom tells us it goes right 3. All right, number 3, we have a little bit of a different scenario because we have this coefficient of 2x. So what we do here, let's go ahead and break this fraction down by taking out a GCF of 2 on the bottom. So if I take out a 2, I'm left with x plus 2. So then I'm going to rewrite this as 1 over 2 times x plus 2, and then plus 2 on the outside. You don't have to do this every single time, but it does help you clearly see that we have a vertical compress or shrink by 1/2. Then it also helps you see that we go left 2. So if we look at our original problem, we aren't going to go left 4. We're going to go left 2 because we took that GCF out. So let's write that down. We're going to go left 2. And then our up 2, we don't change. We still go up 2. So I would like you to, over here in this blank space that you have, I want you to try one on your own that's kind of a little different. So I'm going to put on your own y equals 1 over 3x minus 9 plus 5. So pause the video, try that, and then we'll go over it when you hit return. So when we go over this one, I'm going to take this 3 out of as a GCF. So I get x minus 3. And then if you rewrite it, you're going to get 1 over 3 times x minus 3 plus 5. And then we just simplify down. So that's going to be a vertical compress by 1/3. We're going to go right 3. And then our last thing we're going to do is go up 5. Okay? So now it says identify transformations and determine the asymptotes. So let's go back up, and look at our original function. So our asymptotes are the line a graph approaches but never touches. So on our parent function, our asymptotes are, we have a vertical asymptote of x equals 0. So that means our vertical asymptote is the one on our y-axis. And then we have a horizontal asymptote of y equals 0. So horizontal, remember, is your y value, a vertical is your x values. So if we look down here, it tells us which is which. So it says our horizontal asymptote is y equals k. So our horizontal asymptote comes from the plus or minus outside of the fraction. And then it also tells us our vertical asymptote is x equals h. So that comes from your denominator. So you would set your denominator equal to 0. So let's look at this first problem. So it tells us to find the transformations first. So let's do that. We have a negative in front, so we're going to reflect over x. And then we're going to go left 2, up 4. So those are our transformations. Now, if we're going to find our asymptotes, we have our plus 4 here. So if we go back to the front page, our plus k is our horizontal asymptote. So we're going to say our horizontal asymptote is y equals 4. And if we think about the graph, if we're going up 4 and our asymptote is y equals 4, these two should match, okay, because they come from the same place in the equation. Then let's talk about our vertical asymptote. So our vertical asymptote comes from our denominator. So we're going to say x plus 2 equals 0, x equals negative 2. So our vertical asymptote is x equals negative 2. Okay, let's look at number 5. So first we're going to write our transformations. So this one has a numerator on the bottom. So I'm going to pull that GCF and I'm going to pull a 3 out and make this x minus 3. So then we can clearly see our transformations. So we're going to vertical compress by 2/3. We're going to go right 3. And we're going to go down 1. Okay, those are our 3 transformations. Then we're going to talk about our asymptotes. So this minus 1 is going to be our horizontal asymptote of y equals negative 1. And our vertical asymptote comes from our denominator. So we can do it one of 2 ways. You can set 3x minus 9 equals 0, add 9 to both sides, divide by 3. So you get x equals 3. Or you can look where we factored at what's inside the parentheses, and they should match. So if you set x minus 3 equals 0, you get x equals 3. So our vertical asymptote is x equals 3. All right, and then our last problem, we have our transformation. The only transformation that we have is up 7. All right, so that means our horizontal asymptote is y equals 7. And our horizontal asymptote, our vertical asymptote, we still take our denominator of x and set it equal to 0. So our vertical asymptote is just x equals 0. All right, so over here in this blank space that you have, I want you to try this one. So find the transformations and the asymptotes. So I'm going to put on your own, y equals 3 over 4x plus 12 minus 5. So find your transformations and asymptotes for that equation. pause the video and do that on your own, and then unpause and we'll go over it. So the first thing we're going to do is rewrite our problem, taking out a GCF on the denominator. So we're going to take a 4, and we're left with x plus 3. And then we bring down that minus 5. So then we write our transformations. So we're going to say vertical compress by 3/4. We're going to go left 3, down 5. Then when we write our asymptotes, our horizontal asymptote is y equals -5. And then our vertical asymptote, we set this equal to 0, so x equals -3. And we're done.